Good day, we'll discuss correlation analysis. So let's start first with bivariate data. What do we mean by bivariate data? So this includes data set that contains two variables by the prefix itself bi, meaning two. So the two variables here are compared to find the relationships between them, and later we'll find if they have a linear relationship or not. Now, for example, we have this a relationship between the height of the son and the height of the father. Are they related? So usually we have that one that if we see a father or a son that is tall, we can or we may conclude that the father or the mother is tall. Okay, there is also this relationship between weight and intelligence. So there is a study regarding this. They studied whether the weight and the intelligence of a person are related. Relationship between height and weight. Okay, so as we grow taller, as we grow old, especially when we are children, as we grow taller and taller, then also our weight also increases. So we can also have this between students, relationship between students' mathematics grades and English grades. So are they related? Some people say yes, some people say no. So relationship between room temperature and ice cream sales, especially when the temperature is hot, then of course I think the ice cream sales increases because of being hot, or the temperature or the room temperature is hot. Relationship between age and systolic blood pressure. So as we grow older, our BP may increase. So do they have a relationship? So relationship between advertising spent and total revenue. So when you do a lot of spending about advertising, when you advertise your product more, do you have an increase in your total revenue? Maybe, and most probably yes. That's why some of the businessmen spend more than millions to advertise their product in order for them to get a revenue. But of course, we'll study this one using correlation if these two are related. Then last example, we have the relationship between the number of hours studied per week and the grades. So are they related? Does it mean that when you have longer hours of study, can you get good grades or GPA? So these are examples of two variables which can be related. Now, correlation analysis. So it is a method of statistical evaluation used to study the strength of relationship between two numerically measured variables. So take note of the word strength. This particular type of analysis is useful when a researcher wants to establish if there are possible connections or relationships between two variables. So in correlation analysis, we're only concerned with the strength of the relationship. So no causal effect is implied. When we say causal, it means that, say for example, this one, that it does not mean that if the father is tall, then it always means that the son will always be tall. Okay. So it's not causative. It's not only the reason that the son is tall. It's not the height of the father. No, that's not always the reason. So no causal effect is implied. Scatter plot. So a type of mathematical diagram using Cartesian coordinates to display values for two variables in a set of data. So the independent variable is plotted along the horizontal x-axis, so this one at the bottom, and the dependent variable is plotted along the vertical axis or the y-axis. So scatter plot, how do we plot the points? So we have, you want to examine a correlation of the annual sales of produce stores on their size in square footage. Sample data for 7 stores were obtained. So we have this data. So basically, since we are using the XY plane or the coordinate plane for our scatter diagram, so we'll just have this one. So this is the scatter diagram. So 1726 is somewhere here, then the 3681 is somewhere here. So the point is somewhere here. So basically, we are just going to plot these points. This is for the X and this is for the Y in order for us to make the scatter diagram. So this is just a plotting of points in XY plane. Now let's have this scatter plot. Scatter plot provides a visual representation of the correlation or relationship between the two variables. It shows the direction and strength of a relationship of the variables. Now let's start first with the positive correlation. So when we say positive correlation, or the both variables are positively correlated, then both variables will have the same direction. So if your first variable increases, the other one also increases. If the first variable decreases, the other one also decreases. So visually, we have this. So as your X increases, this one at the bottom, look at that, so it increases, your Y also increases. Okay, so we have this. Now look at this. If our Y decreases, this one, I mean our X decreases, so pa left, then also look at this, our Y also decreases. Okay, so this is a positive correlation when both of these two variables have the same direction. Now example, the IQ versus the academic performance. Of course, if your IQ is high, your academic performance is most probably high. Then of course, salary versus job satisfaction. So the more we have a bigger salary, then we are satisfied with our job. Scatter plot, negative correlation. Now, in negative correlation, we have these variables have opposite direction. When one of your variable decreases, the other one increases. And if the other variable increases, the other variable decreases. So it's just like they are inversely proportional. So the positive correlation is directly proportional. The negative correlation is the inversely proportional. So look at this. As our Y or X decreases, this one, as we go from right to left, of course, our Y increases. Okay, and this one, as our X increases from left to right, look at this, our Y decreases. Look at that, it decreases. So example, academic performance versus number of hours playing video games. Okay, so the more you play your video games, it is expected, of course, that your academic performance will be affected. Next, stress versus job performance. So if you are stressed, then of course your job performance is most probably affected. Last, we have the zero correlation. So it means that there is no apparent relationship between the two variables. So example, your shoe size versus the salary. So it doesn't have any connection. Okay, your ID number versus your job ranking. So they don't have any connection at all. So zero correlation. Now let's go to the strength. So the strength of correlation is determined by its numerical value. Take note of this numerical value. It may be perfect, very high, moderately low, very low, and lastly 0. So visually we have this. We have a strong positive correlation if it if your scatter diagram or scatter plot looks like this. So it is almost a straight line. This one, a weak positive correlation, so we can also say or see a somewhat a line. Now this one next is a negative correlation. So we have this straight line, but of course it leans to the left. A weak negative correlation. We have this moderately negative, and of course no correlation at all. So if you notice that if you cannot see or you can't estimate by just seeing the plot of points, you can estimate that or you can't visualize that there is a line, then of course there it has no correlation. But if you can visualize that there is somewhat a line that you can draw, then we have a correlation. So it just depends whether it's strong, weak, or moderate. Of course, to support or to know whether it's strong, weak, or moderate, we'll go now to the Pearson product moment correlation. So it is most widely used in statistics to measure the degree of the relationship between the linear related variables. So take note of that, linear related variables. So we have this coefficient R. This will now describe the strength and the direction of the linear relationship between the two quantitative variables. So we have this formula. So the following summarizes the correlation coefficients and strength of relationships. So if you search the Google, there are also other summary of the correlation coefficients. So for us, let's use this one. If R is equal to 0, then no association or correlation at all. If our R is between 0 to positive or negative 0.25, then it is very low correlation. Okay, very low correlation. If it's positive 0.25 between these 0 to positive 0.25, then you'll just add positive, very low, or positively very low, or very low positive correlation. Okay. Next, if it's negative, then of course negative, very low negative correlation, or negative very low, or negatively very low correlation. Next, we have this third 0.25 to 0.50, moderately low correlation. So you'll just add positive or negative, whether your R is positive or negative. Okay, 0.50 to 0.75, we have moderately high. 0.75 to almost 1, it's very high or strong. Then if it's equal to 1, then it's positive, perfect positive correlation. If it's negative 1, perfect negative correlation. Example, a sample of 6 children was selected. The data about their age in years and weight in kilograms were recorded in the following table. What is the relationship between the age and weight of these 6 children? So we have this first column, we have the 6 children, and we have their respective age and weights. Okay, so for our solution, take note that this is our equation. So we need the n. Our n here is 6 because there are 6 children. Then we need the xy, so summation of xy. So we can add, or we must add a column for xy. We have x, so we have here. We have y, we have here. Then at the denominator, we have x squared. So we have here, add a column for x squared, and add a column for y squared. Then at the bottom, we'll have the summation for each column. Okay, so we have here from our equation that we have Lots of summation symbols. So after this, let's fill in the table. So x squared, meaning we'll just square all the x. So 7 squared is 49, 6 squared is 36, 8 squared is 64, 5 squared is 25, 6 squared is 36, 9 squared is 81. Similarly, for y squared, we square all these y values. So we have this. And the last column is just the multiplication of x and y. So 7 times 12 is 84. 6 times 8 is 48. And so on until 117. Okay, at the last row, we have all the summation. So just sum up this upper column. So 7 plus 6 plus 8 plus 5 plus 6 plus 9 is equal to 41. Next, we have 12 plus 8 plus 12 plus 10 plus 11 plus 13. You have 66. And so on. So just add, and add. So now we're ready to substitute these values to our equation. So we have these values. These values here are from this table at the bottom row. Okay, so this is our equation. So we have here our n is 6. Our summation of xy is 461. So we have here. Our summation of x is 41. Summation of y is 66. So we have this in our numerator, or on our numerator. Now let's go to the square root in our denominator. We have 6. Our n is 6. Summation of x squared. So this one, 291. Minus, take note of this notation, summation of x. You sum first and then you square the sum. So we have here 41. The summation of x is 41, and then we still have the square symbol. Okay. Next, multiply this by n. We have 6, and this one is summation of y squared. So summation of the squares. So we have 742. Minus again the summation of y, which is 66, and then we have this square. Okay, using your calculator, 6 times 461 is 2,766. 41 times 66 is 2,706. Then at the bottom, we have these values. The first one, this group, we have 65. The second group here is 96. So our numerator is equal to 60. Our denominator is equal to square root of 6,240. So you can use your calculator. This is equal to 0.76. So our R now is positive 0.76. So let's go back to this one. 0.76 is here. So very high or strong correlation. So therefore we have this. This indicates that age and weight of children has a very high or strong correlation, or positively high or positively strong correlation, or correlated. That is, an increase in age is highly associated with the increase in weight. Okay, increase in age is highly associated with the increase in weight. Example 2. Scores of 5 students in mathematics and physics are recorded below. Is there a relationship between their mathematics scores and physics scores? So we have this table, this data below. We have 5 students with their respective math and physics scores. So again, this is our equation. So we just add 3 columns, the x squared, the y squared, and the xy, and at the bottom we have, or we must compute for the summation for each column. So we have this. So again, for this x squared, so 55 squared, we have 3,025. 93 squared, we have this. 89, we have this. 60 squared, 36, and 90 squared is 8,100. The same thing will happen with y, so just square all these y values here. And then at the last column, you just multiply 55 times 66. We have this. 93 times 89, this one, until 7,560. Then at the bottom, of course, you just add 55 plus 93 plus 89 plus 60 plus 90, a total of 387. Similarly, we do the same, do the same, do the same, then do the same. So we have these values now. So let's go to our equations. So we have this data from our table. So this is our equation. So substitute, our n is 5. Summation of xy is with this 3953. Summation of x is 387. Summation of y is 385. So this one. Now the denominator, we have n is 5. Our summation of x squared is 31295 minus summation of x 387, then squared. And we have another one, 5 times summation of y squared minus the square of the summation of y, which is 385. Then again, use your calculator to compute. You have these values, this. So our r is equal to positive 0.90. So again, this is a positive correlation. So going back, so still we have this result, very high or strong. So since this is positive, so positively very high, positively very strong. So this indicates that math and physics scores have a positively very high or positively very strong correlation. That is, a high score in math is highly associated with a high score in physics.